Good afternoon, everyone. So, how is your sessional exam? Good. Okay. What was the last class? Anyone? Can you tell me? In last class, what did we study? What happened? No one is there or what? On 25 to 30 students doing regular classes, and what about others? But exam is given 40, 43 out of 40 students, 43 students. Those who are not doing the classes, they have given exam and carrying good marks. How? Okay, last class we have discussed about canal, isn't it? Canal head regulators, isn't it? And let's see what are the topics. So I think we have discussed these things, inlet and outlet. What is inlet and what is outlet? And then we have canal channels. What are the channels? What are the different shape of prismatic shape maybe of a canal, and the channel may be prismatic. So already you know this prismatic channel. Fifth semester you have got about prismatic channels, open channel, isn't it? So this is open channels. Irrigation water is conveyed in either open channel or closed conduits. Open channel receive water from nasal streams and convey water to the farm for irrigation. Open channels have free surface, and the free surface is subjected to atmosphere pressure. The basic equation used for water flow in open channels are continuity equation, Bernoulli's equation, and Darcy's Weisbach equation. These things already you know about open channel, isn't it? And prismatic and non-prismatic channels, a channel in which the cross-sectional shape, size, and the bottom slope are constant over the boundary of the channel. That type of channel is called prismatic channel. And Most of the man-made structure, man-made artificial or artificial channels are prismatic channels. The rectangular, trapezoidal, triangular, and half circular are commonly used shapes in man-made channels. All natural channels generally have varying cross section and consequently are non-prismatic. So those who have varying cross section, these are called non-prismatic channel. For design of an open channel, you have to know the area of cross section, weighted perimeter, hydraulic radius, hydraulic slope, freeboard, and what is the economical section? A channel section is said to be economical when the cost of construction of the channel is minimum. And next, the cost of construction of a channel depends on depth of excavation and construction for lining. The cost of construction of channel is minimum when it passes maximum ditches for its given cross-sectional area. It is evident from the continuity equation and the uniform flow formulae that for a given value of slope and surface roughness, the velocity of flow is maximum when hydraulic radius is maximum. The condition to for most economical section, what are the condition? Let's see. A rectangular channel section is the most economical when either the depth of flow is equal to or half of the bottom width or prismatic radius is equal to or half of the depth of flow. A trapezoidal section is most economical if half the top half the top width is equal to one of the sloping sides of the channel or the hydraulic radius is equal to half of the depth of flow. R equal to if R equal to d by 2, then that trapezoidal, in that case the trapezoidal section is said to be economical one. Okay. And next, triangular section is most economical when each of its sloping side makes an angle 45 degree with vertical or half square described on a diagonal and having equal sloping. And Ditcher's equation already you know Q equal to AV. Manning's equation says this equation. Okay, so next we have canal alignment. So from irrigation, I think it is clear that irrigation water in flow type which reach the field by gravity. To accomplish this requirement, irrigation canal is always aligned in such a way that the water gets proper command over the whole irrigable area. Next, if the canal follows a watershed or a ridge of the drainage area, it will get necessary. I think I have some network problem. I don't know why my voice is breaking, but it is showing here. It is showing good network. Okay, the drainage area it will get necessary gravity flow. The watershed or the ridge is a dividing line between the two drainage areas. Thus, a canal which runs over the ridge gets command of area on both sides of the ridge. So, irrigation canal can be aligned in three ways: as watershed canal, as contour canal, and as a slight slope canal. Okay, these are the three ways alignment of canal is done. So, what is watershed canal? What is watershed actually? Why, who are giving me attendance in WhatsApp group? Okay, someone have a bad connection, then it's okay. But don't others. So generally, watershed means an area, okay, where uh, all the water that may be rainfall, that may be drainage water, that may be surface flow, that is surface subsurface flow. If all the water, the common outlet is called watershed, okay, where all the water joins, that is a watershed and it is common to all. So a watershed is an area of land that drains all the streams and rainfall to a common outlet, such as the outflow of a reservoir or any other point along a stream channel. So a watershed contains common set of streams and rivers that all drains into a single larger body. That is your meaning of watershed. Okay. So, what is watershed canal? The dividing line between catchment area and the two drains is called watershed. Thus, the two major stream. There is the main watershed which divides the drainage areas of two. Similarly, between arbit- any tributary and main stream, and also between any two tributaries, this okay, dividing the drainage between the two streams on either side. Now my voice is clear. Okay. Next is your contour canal, contour alignment. So in contour alignment, the canals along the watershed is not possible in hilly area. So contour alignment is adopted in hilly areas. In the hills, the river flows in the valley, while the watershed or the ridge line may be hundred of meters above it. So it is becomes uneconomical to take the canal on top of such a ridge. So the channel in such a cases is generate sufficient flow velocities are given. Next is side slope canal. A side slope channel is that which is aligned at right angles to contours. That means these are the side slope channel and these are the ground contours. Along the ground contours, the canal is aligned. Such a channel is parallel to the natural drainage flow and hence does not intercept cross drainage. Hence, no cross drainage works are required. Next, there are some precautions in alignment. While doing the alignment, the canal should be aligned on reed in such a way so as to obtain maximum command. Maximum command means that means maximum profit. So far as possible, canal alignment should be kept in center of the commanded area. The canal should be aligned in such a way that length is minimum possible. The canal should be aligned in such a way that the length is minimum. You have to keep in mind that the length of the canal is minimum. The alignment should avoid inhabited places like roads, railways, properties, places of worship, etc. Canal should be taken through the area where subsoil formation is favorable. Waterlogged areas should be avoided. Where the soil contains alkalinity, salinity, rocky soils, boulders. So that type of soil, you cannot construct a canal. That means you cannot align along that type of soil. Next, the alignment should be straight as far as possible. Where alignment is not straight, simple, circular curves of large radius should be provided. To ensure economy, the alignment of the canal should be such that excessive cuttings and fillings are not required. The alignment should not cross hills or depression. Next, someone is getting away. To ensure economy of the alignment, the canal should be such that excessive cuttings and fillings are not required. So for a economical section, you have to keep in mind that there should not be any cuttings or fillings. That means there should not be in more artwork. The alignment should not cross hills or depression. So these are the points. Keep in mind while align a canal for irrigation. Next, let me check. So where what are the precautions you should um, taken while aligning a canal? So these are the points you have to remember. So next is your canal lining. One is most important topic in irrigation engineering, that is your canal lining. So what is canal lining? Canal linings are provided in canals. That means suppose this is your canal, in the side you have to line the canal. Okay, some coatings are given along the sides of the canal. That is your canal lining. Canal linings are provided in canals to resist the flow of water through its bed and sides. This can be constructed using different materials such as compacted earth, cement, concrete, plastics, boulders, bricks, etc. The main advantage of canal lining is to protect the water from seepage loss. Canal lining is an impermeable layer provided for the bed. That means in the bottom and the sides of the canal, some lining is provided, which is impermeable. That means water cannot pass through the canal lining. Okay. Uh, to improve the life and ditcher's capacity of canal. 60 to 80% of water lost through seepage in an unlined canal. So to prevent the water loss, we have to line the canal. Canal um, can be shaped by constructing canal lining. So that is your canal lining. That means some impermeable layers coatings is provided in the canal sides and beds of the canal to prevent water loss. So what there are different types of canal lining. Uh, Canal linings are classified into two major types based on the nature of the surface, and they are number one is ardent type lining and hard surface lining. What is ardent type lining? The ardent type lining are again classified into two types, and these are compacted earth lining and soil cement lining. Compacted earth linings are preferred for canals where earth is available near the site of the construction or in situ. सो जहाँ पे तुम लोग कैनल बना रहे हो, अगर वहां पे बहुत ज्यादा आर्ट है, साइड में मिट्टी है ज्यादा, तो यू कैन अडॉप्ट आर्ट compacted art lining. Okay, if the art is not available near the site, then it becomes costlier to construct compacted art lining. Because why? Because you have to carry art soils to the ground, you have to transport art from another place, and that will be costlier because transportation cost will be there. Compaction reduces soil pore size by displacing air and water. Reduction in void size increases the density, compressive strength, and shear strength of the soil and reduces impermeability. This is accompanied by reduction in volume and settlement. So proper compaction is essential to increase the stability and frost resistance and to decrease erosion and seepage losses. Okay. Next is soil cement lining. Soil cement linings are constructed with a mixture of sandy soil, cement, and water, which harden like a concrete like material. The cement content should be 2 to 8% of the soil. However, larger cement contents are also be used. Generally, 2 to 8% of cement is used, but you can use larger amount. In general, the construction of soil cement linings following two methods are used: dry mix method and plastic mix method. Okay. For erosion protection and additional strength in large channels, the layer of cement soil is sometimes covered with coarse soil. It is recommended the soil cement lining should be protected from the weather for 7 days by spreading approximately 50 mm of soil, straw or Hessian bag, bakes cover over it and keeping the moisture. Okay. Next is a hard surface canal lining. Number one is your ardent type lining, and next one is hard surface canal lining. So what are the hard surface canal lining? One is cement concrete lining, brick lining, plastic lining, and boulder lining. So in cement concrete lining, what will happen? That means the lining is okay. So, in cement concrete linings, they are widely used with benefits justifying the relatively high cost. They are tough, durable, relatively impermeable, and hydraulically efficient. Concrete linings are suitable for both small and large channels and both high and low flow velocities. They fulfill their every purpose of lining. There are several procedures of lining using cement concrete. These are cast in situ lining, short precast concrete lining, shotcrete lining, and cement mortar. What is short? So there are some advantages of canal lining. If you line a canal, what should be the advantages? It has seepage reduction. The water cannot uh, flow. That means water cannot drain out. Water cannot percolate if you line canal. Okay. So next is prevention of waterlogging. There is no waterlogged if you line canal. Increase in commanded area. Why? Because there will be no loss of water. More water will be irrigated to the crop, and you will have more commanded area. Increase in channel capacity, less maintenance, and safety against floods. These are the advantages while you do canal lining. Okay, can you study yourself these advantages in detail? I will send you the notes. You study yourself. Okay. Oh, I have not given any assignment to you. For assignment, I have to give one assignment to you. Next, Kennedy's silt theory. This is again very, very important. So, R.Z. Kennedy investigated canal system for 20 years and come up with a Kennedy's silt theory. So, he studied for 20 years and ultimately gave a conclusion related to silting, that is called Kennedy's silt theory. The theory says that the silt carried by the flowing water in a channel is kept in suspension by the eddy current rising to the surface. So while what if water flowing through the canal, there will be some silt there. That means there will be some uh, debris, isn't it? It may be small debris or it may be larger particles. So these are called silt. If water carries some other materials with them, then that is your silting. So the theory says that the silt carried by flowing water in a channel is kept in suspension. The silt is in suspension. Why it is suspended? Why these are suspended material? Due to the eddy current rising to the surface. Eddy currents mean these are rotational type of current, three-dimensional flow of water. Okay, these are your eddy current. This type of current. That not current in electricity. These are the water current. Okay. Assumptions they have made. So Kennedy have assumed some assumptions and they give following conclusion. He given one general form, mathematical formula for to find out the critical velocity. Okay, so my syllabus left only Kennedy's seal theory and after the Lacey's seal theory of canals. Then we have this regime. Drawbacks of Lacey's shield theory. After that, the last chapter, we will have water management in irrigation. Some techniques, modern techniques is developed, how it is works, only that part, and maybe two, three more topics is left. So by zone last week, as I think my syllabus will over. I think your exam will be on July. Don't know. Not sure. I'm okay. So, so 33 students. Can you write your enrollment IDs in chat box? So, uh, EM Jungar Kichu, are you present?
Yes, ma'am.
Are you present today? So you
Yes,
have
ma'am.
not done any classes earlier. Why?
Yeah. Because I was
Today is
attending
your
another
first
class.
class?
Yeah, yeah.
Okay.
I didn't know that I was having this class or was attending other sections.
Okay.
Sorry,
So
ma'am.
next session Kiri, are you there? Absent. Next, Kesi Losung, Pranay Chakraborty. Absent. Margak Maya, Margak Maya.
Yes,
Absent.
ma'am.
Are you there?
Ji, ma'am.
Why I have not done it? And Omit Pangak, he is always absent. But he has given sessional exams and scored good marks also. I don't know how. His attendance is totally zero. Next, Tokototo. Are you there today? Tokototo? No. Okay. Others they are generally present in all my classes, but these students they have some exception. Anyone left to write enrollment IDs? Oh, today, Rupasri, are you present? Rupasri?
Ma'am, present ma'am. Present ma'am.
Okay. আগতে কি তোমাৰ ক্লাছ কৰা নাছিলা মানে so সুধিলো ঠিক আছে okay you can leave